Hello, everyone. Thanks for being here. We are going to talk about a topic that is rapidly shaping the future of secure cloud operation. As you are all members of PCI Security Council, and I think we share the same concern, protecting data of our customers while enabling innovation. And that's where comes the problem. Or we can keep a highest level of security while embracing the power of cloud, scalability, elasticity, agility. That's where confidential computing comes in. May I ask you a question? Do we have experts in confidential computing here? Welcome. Do we have people who knows roughly what is confidential computing? Okay. And last question, do we have people who has implemented already some confidential computing in a product on the cloud? Ah, you did it. So we have to discuss after the call. Okay. So basically you can see this is a very early stage technology. Okay. So what we propose you is to come back on confidential computing techniques first. Then we will share with you what we have implemented as a proof of concept in our platform of payment in Thales. Then you will see that it can fit totally with PCI requirements in terms of security. So at the end, I hope you will share the same point of view. Confidential computing is not only an enhancement of security. It's really a game changer in the way we are going to think the trust on the cloud.
My name is Cyril Solé. I am a principal engineer at Thales, working in the payment business line. So we are working on cloud services for customers that are banks. So we are PCI DSS compliant.
I am Bruno Besson, CTO of Pay Business Line. My role is to lead the techno roadmap and the innovation. And I am proud as well to be the Thales representative on PCI Council and at board of advisor. Sorry. So, few words about Thales. Thales is a global organization. We have more than 80,000 people in the world, in 68 countries. Our motto is to help our customer in their decisive moment with trust. Our main segment, we have three main segments. You probably know. One you know probably because Thales is well known in it. Defense, aerospace, and cybersecurity. About cybersecurity, we are from this business segment, and we are in the payment business line. The payment business line delivers product, service, and solution to more than 3,000 issuance institutions. On the top of that, we deliver massively some cards to the market. We are one of the leaders. But on the top of that, we have developed a new platform to help our customers to modernize their current program and activate digital services. The platform is called D1. This platform is a SaaS platform used in more than 60 countries and already having more than 180 million records in the system.
So let's speak now a little bit about confidential computing itself. Not everybody is familiar with confidential computing, so we believe it's good to start with a definition. So we took this definition. Confidential computing is a security and privacy enhancing computational technique focused on protecting data in use. So we have a set of mechanisms to protect data in transit, at rest as well, but here what we're going to speak about is protection of the data in use. So how confidential computing protect data in use is by providing a hardware-based systems, mechanism, and an attestation mechanism that makes sure that something running in the confidential computing unit is attested to be there and attest to use other system of the global solution. So typically, when it comes to the implementation, we are looking at a chipset manufacturer, like company like Intel or AMD. They are providing as part of their new architecture what we call a TEE, or Trusted Execution Environment. It's a confidential part of your chipset where you can run safely your data, your code, your algorithm, without being exposed to the rest of the system. Like it's a perimetric protection, it's what we call an enclave.
Let's try to position confidential computing in the trust chain of the payment. On one end, you have traditional system stack relying on HSM. HSM is the state-of-the-art for encryption, for protecting the keys, and has the drawback, as you know, that scalability is limited. Elasticity, I don't talk about it because it's difficult to manage. But this is the state-of-the-art of the security hardware modules that we can use. On the other end, you have your cloud computing VMs, highly scalable, but in an untrusted environment. You have to see confidential computing that the bridge that you can do between these two worlds. You want to bring highest level of security with the highest level of scalability and elasticity. It's where we have to position confidential computing. It's how we present it.
So, thank you, Bruno, to introduce the cloud in this picture, because now let's speak about what could be confidential computing in the cloud, what we call cloud-based confidential computing. Well, let's start very simply. You can just use chips that are enabling confidential computing within a cloud offer, within a cloud provider. So most of the leaders of this industry are proposing basically Intel or AMD or equivalent technologies that you can use. But if you look at one particular actor, AWS, they are proposing a disruptive approach, or something considering disruptive, because where they implement the hardware to protect your enclave is not going to be at the chip level, but at the hypervisor level. So if you look at the hypervisor of this cloud provider, it's a set of hardware and software and firmware that protect top-down the underlying infrastructure of your cloud VMs. So it's still hardware-based. It also proposes an attestation mechanism that you can leverage. And if you look at the definition that AWS itself provides on confidential computing, it's a definition of use of specialized hardware and associated firmware to protect customer code, so our code, customer data, our data, the data of our customer, during the processing from the outside access. So we are not here to speak too much about this technology, but we give you a link that if you would like to know more about confidential computing at AWS, we encourage you to have a look at.
Now let's come to the use case and our SaaS platform where we have implemented this proof of concept on confidential computing. Next. One thing we want to remind is we are doing technology, we are doing confidential computing, but first of all, we are doing product for customers. And we have three key principles that are key for us, and we do not compromise any of them, okay? So security, for sure, we are here for security and compliancy. We want the best stack in terms of security to protect the customer data. But scalability is as well something that we cannot afford. And this is a must in our design and in the permanent evolution of our system. Third, we build platform to integrate customer, to onboard customer. So a very important point for us is even if we bring technology, even if we bring a lot of improvement, we need to be able to keep a capacity to onboard the customer very fast and easily. So this is the 3 key principles that are key in our design and evolution of the platform. And now back to the use case. So D1, our D1 platform is a SaaS platform, cloud native, Amazon, API-based, and deliver various services to our customer. Tokenization request, token push, 3DS, all these features are offered by this platform. We have decided to apply confidential computing on a very simple use case, how to display information on the mobile with confidential computing.
So let's go a bit more in the architecture level of the use case that you introduced, Bruno. This is an extremely simplified version of our cloud platform. What we can see in this infrastructure is that we are using 2 cloud providers, AWS and GCP. We are doing our business logic is implemented in AWS. So we are mainly a microservice-oriented architecture. We are using containers. We are using any service that allow us to go fast, to be agile, and to develop introduce our feature extremely rapidly. On the other side, we have in GCP a cryptographic cluster composed by our HSM, Thales HSM. We are using both Luna HSM and PayShield for different reasons. General cryptography on one side, payment functions on the other side. And in this cryptographic cluster, we are also using a software component that we call Thales Key Management Service, Thales Key MS, which is basically the responsible of arbitrating the cryptographic operation, hardening them, and most important in this presentation, doing the key management. So this is where we're gonna manage the lifecycle of the keys. By the way, this is why I put this small database icon to really focus on where the keys are managed. So this environment is in production today, so we are running most of our services on this kind of architecture. It's PCI DSS compliant. It's also in line with what we call at Thales our zero trust approach. Zero trust means that we are actively using cloud, but we do not trust 100% the cloud. So this is a technological partner for us, but we have to do our job to make it secure and extremely zero trust. And the fact that we are using 2 cloud providers is part of it. Now, where are we going to place in this POC? So we did a POC with this study. We're going to place the confidential computing. Well, the confidential computing is going to be a layer between what is the cloud computing, traditional microservice-oriented architecture, and the cryptographic cluster. So several things to mention in this diagram. The first of all is that we have introduced a particular component in the confidential computing layer, which is called Nitro Enclaves. So this is part of AWS subset of service. And what we can see as well is that in that Nitro Enclave, we are running a Thales Key MS with a slightly different color, because it's a slightly different version. It's a hardened version adapted to run in an enclave. An additional detail is that this enclaved Key MS, let's call it this way, does not have any database icon, because we are not doing key management in that enclave. And we don't want to do that because it will make the things much more complex when it comes to the operation. But we do have a secure channel with a small tunnel in blue that is a proprietary secure channel we have implemented in our POC to make the 2 Key MS connecting together. And an important point is that when we establish this secure channel, we are using the attestation mechanism that is coming from the AWS Cloud Confidential Computing offer. And for the rest, well, you can see that by that architecture, we are extending our cryptographic capacity on the AWS side of our solution, but within a perimetrical controlled area, which is the enclave mechanism. So in a sense, you can see this confidential computing layer as a kind of secure proxy of what we are doing naturally with our cryptography cluster and with our HSM. So that was our study, that was our implementation, our POC, and we were looking at the challenge, the opportunity, and how to go next with this technology, and we wanted to share that with you mostly today. So let's start with some achievements, where, a very positive achievement that we believe in terms of industrialization of this technology is really a way for us to enhance what we call our cryptographic capacity, the D1 cryptographic capacity, while keeping very strong foundation, very strong key principle when it comes to key management, which is an extremely important aspect of the Thales engagement. First of all, latency is extremely reduced. You have seen on the graphical before that because you can now offload a certain category of general purpose cryptography in the AWS cloud, then of course back and forth to the HSM are limited. Enhanced crypto elasticity, Bruno, you mentioned that, it was our main objective. Of course, because while it's definitely doable to do scalability in an HSM, it comes at a cost. It's more like capacity planning approach. Here, we really have elasticity because you can scale out and scale in enclaves just like you do VM. We still have a strong key management within our cryptography cluster. We do not duplicate key referential, and that's extremely important for us. And it's still in line with our zero trust approach because we still have these two cloud providers. It's true that we have extended cryptography operation on the first cloud provider, but in a confidential way.
Now, few key learnings after this very promising result. We wanted to share that with you. So, for tech guys, we want to share with you that it's not given to start to work with confidential computing. So we have put our best expert on it in cryptography and in cloud to make it happen. So it has been extremely quick, but definitively the entry cost is significant in terms of expertise, knowledge, etc. Okay? So you have to keep that in mind. If we go to Nitro technology, some of you will say, but you are stick to Nitro technology, so potentially, which is Amazon, by the way. So it's a concern potentially if you are looking for agnosticity on the cloud. But the good point of this technology, it is our point of view, it is the most mature of the market. Very well integrated in the ecosystem of Amazon, very easy for experts to use. So definitively, the point of proprietary technology for us is balanced by this maturity. Third point, you know, in the cloud, we are deploying a lot of monitoring and observability capacity, and which is key, by the way, to monitor our production. For sure, with confidential computing, you include in the cloud some boundaries with this specific enclave. So your monitoring, your observability will need to be adapted. You will not be able to do the same things that you do on the cloud. And last but not least, one tip for people who want to develop, just a small tips, keep your code very lightweight. This is a must to keep the control on your stake.
So that was our last slide. Thank you a lot for your attention today, and I hope we learned something together about our study, our POC, and our results. Thank you, Bruno.
Thank you, everyone.